In this very interesting series on modulus, in the last one we discussed the basic properties and the basic definition of modulus. In this current one we are going to deal with graphical transformations. What are the 4 basic graphical transformations that we can do while dealing with modulus? And then we'll look into some good question. This will also contain a homework towards the end that if you do, it has been given with answers, you are going to benefit a lot. So without any further delay, let us start with it. Now let us look into the next idea, that is graphical transformation. Now the basic thing that we need to start with is the basic graph of modulus of x. So if you have modulus of x, then it will usually have 2 parts. One where the function inside the modulus is greater than 0. So if I take the very basic function f of x is equal to modulus of x, then it will have 2 parts. One part on the right hand side where x is greater than 0. And the other part where it will become x when x is smaller than 0. You can see that this graph has a split personality. Now there are 2-3 things we will want to know in this transformation. The first one is what happens if you have been given a graph of this form, y is equal to mod of fx. So what we are doing is we are putting the modulus over the function, and for demonstrating this I have taken the simplest of function, that is x minus 2. So what will happen in this case? So there are 2 steps involved. In the first step, whatever is inside the modulus, that graph we are going to draw, that is x minus 2. Now this graph is very simple to be drawn, x, and then this is the graph of y is equal to x minus 2. If you don't know this graph, I will want you to do one more transformation and get this graph. So let us say that you don't know this, then a way forward would be to go down. I think this everybody knows, but still for the sake of fulfillment, let us do it. So this is the graph. So if I subtract 2 on the right hand side, it goes below. So this will become minus 2. This is your 0. And this point becomes plus 2. Now once you have this, if I want to draw the graph that is asked to me, what we are going to do is, see, modulus, whatever goes inside it comes out as a non-negative value. So whatever is this negative value of the graph, this will be same but positive. So what we are doing is, this part where it is positive we are keeping it intact, but where it becomes negative we take the deflection. Because if the value here is minus 2, then the value on this side would become plus 2 because we are taking a modulus over it. So the graphical transformation goes like this. In the first step, you will have to draw graph of fx. Once you have done that, you will have to take reflection of graph below x-axis and you have got your answer. So these are the 2 steps that you can take to draw graphs of similar nature. Another important transformation would happen if I put modulus inside the function. So what we are doing now, this is an example of inside the function you have put a modulus sign. What to do in this case? So again we will start with the same logic. We will first draw the graph of function without the modulus sign, and then if you don't know this, you can also start with y is equal to x, because this graph everybody knows. So we can start from here, draw the graph for y is equal to x. Once you have done this, the next part would be to pull it down like we did in the last part by 2 units like this. So this becomes minus 2, this becomes plus 2. Now once you have done that, now what is happening is we are putting a modulus sign over x. What does this fundamentally mean? See, this fundamentally means that if you put value of plus 2 in this, you will get 0. But more importantly, if you also put the value of function as minus 2, this modulus will make it positive. And then again if you subtract minus 2, it becomes 0. So what we are saying is, the value at x, assuming that x is positive, and minus x, both of these values are becoming same. The reason is that there is a modulus inside the function sign. So how do we counter for that when we are doing graphical transformation? That is interesting. So what we can do is, we can take this graph that we initially had, and in this graph just draw the graph that is on the right hand side of x-axis. So let us draw this part, and then what we are saying is whatever is on the other side. So, this part of the graph that was on the left hand side, we are skipping this part, and whatever here on the right hand side, we are taking its reflection. So, this pink part goes away, but on the other hand, this yellow part gets reflected. So, now you can see that this is plus 2, this is minus 2, because the value corresponding to minus 2 in the function will never come. For minus 2, you will get the same value as plus 2. So, these two values will become same and the graph will reflect corresponding to y-axis. So, let us write down the steps. In the first step, you are going to draw the graph of y is equal to fx without the modulus sign. In the second one, we are going to remove part of graph on the left hand side of y-axis, and in step 3 take reflection of graph on right hand side of y-axis on y-axis. So, what I have said is very simply remove the pink part, and the yellow part that we have, we need to take reflection over y-axis. Interesting thing to observe that in this case the reflection happened over y-axis. In the earlier case, the reflection happened over the x-axis. This is something that is very fundamental and we should always remember. Now, let us take a third case, though not exactly in JEE syllabus, sometimes it is asked in JEE Advanced, this kind of graphical transformation. So, what we are saying is what happens if I put a modulus over the y sign in the fx equal to fx. What happens in this case? I have taken again very simple example to illustrate my point. So, if I take this part, what you can see is first we will have to again go back and draw the graph of y is equal to fx or y is equal to x minus 2. Even if you do not know that, we will have to go back and draw the graph of y is equal to x. That is very simple. So, this is how this graph looks like. Once you have this, you drag it 2 units below the y-axis. This becomes minus 2, this becomes plus 2. See now what is happening. See, understand this. If I put modulus of y is equal to minus 2, what happens at 0? You can see that corresponding to this, there would be no value of y, because modulus can never be negative. So, in this case, you will get nothing. So, y belongs to null set. This is impossible. Wherein, if it becomes a positive value like 2, in this case, you will get two answers. Y can either be equal to plus 2 or y can be equal to minus 2. See, keeping this into mind, what we are saying is, if I draw the graph of modulus of y is equal to x minus 2, what is going to happen? The plus part we are going to retain, negative part will let go. So, this portion below the y-axis, x-axis, we are letting it go. We are focusing on the portion above. So, this portion I have drawn here again. And now, what we are saying is the same part will get reflected here like this. This is important and this is new. Why is this happening? Because if there is a value of y 2, then correspondingly the value of y for mod of y equal to 2 can also be plus 2 and minus 2. And that is the reason this kind of a curve will appear. So, if I want to write it down, what are the steps that we have? So, 3-4 steps we will write. The first step would be draw a graph of y is equal to fx. Once you have drawn this, remove the part below x-axis. Third, take reflection of part above x-axis below x-axis. So, what we are saying is whatever part we got above, we are taking reflection below as well. So, these are the 3 simple steps that you can use. Now, let us consider some more examples on similar ideas so that we can gain one more level of clarity by doing it one more time. So, you can see that this is one in which there is a modulus over the function. So if I want to draw this graph, again the steps were very simple. You draw the graph of y is equal to fx, because this was the step in all the questions that we did. So here, since the fx is x plus 2, we'll write x plus 2. For drawing this, if you don't know this, you will draw y is equal to x. So what we have is y is equal to x, something like this. And then y is equal to x plus 2. This will get now shifted above. So this becomes plus 2. And now what we are saying is, whatever is the graph below the x-axis, this part will get reflected. So this part will get reflected, and ultimately my graph is going to look something like this. This point is minus 2, because at minus 2 it was becoming 0. If I take another example in which in the same question, if instead of x I write modulus of x, what happens in this question? Let us repeat one more time. So in this kind of question, again you will start from y is equal to fx. For that, what we will require is y is equal to x ka graph. This is one graph that everybody knows. If I take this is how it is going to look like. And once you have this, you can shift 2 unit upwards. So this is what we did in the last part also, but now what we are saying is, in this case, the part that is on the left hand side of the y-axis, this we will let go. We will only focus on the part on the right hand side of the y-axis, and then we are going to take its reflection over y-axis. So this is the part that we had, and then we are taking reflection over y-axis. This is the final graph that appears. Again, here reflection is happening over y-axis. In the earlier question, it was happening over x-axis. This is the fundamental difference. If we go into the third kind of graphical transformation, what happens here is, we have put a modulus sign over the y, and then we are writing fx. So again, we will follow the same steps. In the first step, I am going to draw the graph of y is equal to fx. If you don't know this, you will have to start with y is equal to x. This is a graph that we can easily draw without any fuss. Y is equal to x. Since it is x plus 2, we will shift it above. Once you have done that, now in this case, what I told you was, remove the part that is below x-axis and reflect the part that is above x-axis on x-axis but below it. So if I draw this, the part that is above, that will get reflected below the x-axis. Here also the reflection is happening over x-axis, but in the first part it happened above the x-axis, here it is happening below the x-axis. Now there might be some scenarios that might not get covered in these three, like this very specific case, and lot of questions are asked on this, so understanding graph of this 4 scenario is also important. So here what we have is 2 linear functions with an addition or subtraction sign. It could be more also. Important idea here is what is inside the mod needs to be linear. This is important. So what we do here, we use a method that I will call as table method. So we are using a method known as table method. So what we will do, we will make a simple table consisting of x and y and see what are the possible cases that can happen. So now we will put some values of x, some values of y. We will get corresponding to those values. So what we will do first, we will take this modulus, put it equal to 0. So if I put x minus 1 equal to 0, the value of x is 1. Let us put it here. This is the first point over which we are going to check value. Then we are going to put the other modulus equal to 0, get the value as 2, put that value here. And then once you have done this, take a value smaller than the smallest value. So let us consider 0. I can take minus 1 as well. 0 is easier to calculate. 2 se badi ek value we can consider as nothing but 3. So here we have taken a value smaller, here we have taken a value bigger. Once you have done that, let us find values corresponding to 0. So if I put substitute the value of x as 0, this will become 5. Wherein if I take the value as 1, it becomes 2. If I put the value as 2, it again becomes 1. And ultimately if I put the value as 3, this will become 2 plus 2, 4. Now once you have got these points, we are going to draw the graph. So what we can do is, we can draw our x and y axis and start plotting these values. The important values are 0, 1, 2, 3. These are the important values. So now here, corresponding to 0, the value that we got was nothing but 5. So 1, 2, 3, 4, 5. Let us note that point. Then corresponding to 1, the value was 2. Corresponding to 2, the value was 1. And corresponding to 3, the value was 4. Once you have got this point, we can connect this point to get the graph. So I can connect the first 2 points. This is the graph that I am getting. I can connect the next 2 points and then the next 2 points. Like this, I can get all the values. Now, once you have done that, you have got the graph of the function. Now, this graph can be used to develop a technique known as graphical technique, that ultimately we are going to use to solve questions faster. So, this will become a shortcut. So, these are the 4 very important types of transformation. In order to illustrate this last one, let us take one more example. I have made it more complex, but it does not change the method. We are still going to apply the table method. It is easy if you remember the names of the method, because then it would be easy for you to connect in your brain. So, if I draw this small table, let us see what do we get. So, again, as I told you, we will put the first modulus equal to 0, get the value corresponding to x there. If I put the second modulus, I get the value of x is 2. If I put the third modulus equal to 0, I will get the value of x is 3. And now we will take a value smaller than the first one. Let us consider that 0, greater than the last one. Consider that as 4. If I put 2, the first one will become 1, the next one becomes 0, and the third one becomes 3. So, this becomes 4. And ultimately, if I put 3, the first one becomes 2, the next one becomes 2, and the last one becomes 0. So, this becomes also 4. And ultimately, if I put the value as 4, the first one becomes 3, the second becomes 4, and the last one becomes 3. So, it becomes 6 plus 1, 10. 6 plus 4, 10. Okay, so, once you have done this, the next step starts. Now, we are going to draw a graph and denote all of these points on the graph. So, once I have this, I can demarcate all the values on the x-axis first. So, 0, 1, 2, 3 and 4. Correspondingly, at 0 the value is 14. So, I am assuming it to be here. It is not possible to draw. Now, 8 would be somewhere here. 2, it is 4. So, let us take in between. Then it remains 4 or 3, and on 4 it becomes 10. Somewhere here. If I connect the points, let us see what do I get. So, by connecting the first 2 points, this is the line am I getting. Here again, this is the line I am getting. Another line and another line. This is an important technique. Using this, again, what I told earlier, we develop a graphical technique which will become a shortcut to solve questions. Now, once we have done that, let us summarize everything. So, this is a diagram that summarizes all the techniques that we have just covered. You can either click a screenshot or go over it one more time by pausing this video. Now, let us take some examples that might not fall into any of these categories, and we will use this technique to solve more complex questions now, because in mathematics we always reduce a tougher question into a simpler question. If I want to draw this part, so what we will do, first we understand that there is a modulus outside. We will want to reduce this modulus first. So, this becomes a 2 minus x minus 2. So, this graph we will try and find, but for that there is a 2 getting added up here. So, for this we will require graph of minus of mod of x minus 2. If I want to draw this, first I will have to draw the graph of x minus 2 mod, and if I want to draw this, I will want the graph of y is equal to x minus 2. And if I keep continuing on the same quest, I will end up with graph of y is equal to x. Now, these are the graphs that are simpler to draw. Y is equal to is very simple. So, this is the first graph. If I pull 2 units below, I get my second graph. And then if I put a modulus over it, now we are using the technique. This is the graph we drew earlier also. It gets reflected over x-axis. and ultimately if I take a mod over it, now what will happen? Whatever is, it will flip signs. So whatever is positive will become negative, something like this. Once you have done this, now you will add 2 to it, and whole of this system will shift above. What is happening is the system is shifting above. You can see, you have to understand, this was at -2. When you took a mod, this became +2. Then again it became -2, and now if you are adding 2, this will be 0 here. This point was 0, this will become 2. This is also +2, this will become 4. So you can understand how it looks like. Now what we are doing again is we are putting one more mod over it. So whatever is below the x-axis, these part will again get reflected. So if you draw the graph of this function, the ultimate graph looks something like this. So you have this portion that is already positive, will keep it intact. Whatever is below x-axis, that part I am again reflecting. So this is how my final graph looks like. So multiple things we have done. What we have done in this step is we have shifted 2 units below. In this case, what you have done is you have used the first transformation. In this case, what you have, if you multiply anything with minus sign, positive becomes negative and negative becomes positive. We have used this idea. Now here, once you have done that, we have shifted 2 units above. So if you add something, the graph shifts above. This idea we have used. And then here, what we can see here is again the first transformation we have used. I hope this should be very clear. If you haven't understood it, watch this one more time. Now, if I make it even more complicated by introducing one more modulus sign, like in this case, how are we going to handle it? So in this case, once you have this, what we can do is we can write this as y is equal to, in fact, we will have to do multiple transformations. So if you remember the earlier graph, it would become simpler, but even if you don't remove, so first we are going to remove this. See, there is a very peculiar way of removing this modulus signs. If you mess this up or do it in your own style, your answer will not match. First we remove over this. Then the next that we are going to do is what we did in the earlier question, we remove this outer wala. Then we are slowly moving towards inside, we will remove this 2. For that you will have to draw this minus of mod of x minus 2, and then for that you will have to draw x minus 2 come out. Now this we did in the last question, and the graph that we got used to look something like this. It was a shape of a W. This is the graph we got earlier. So what are we saying now? What happens when we do this transformation? What is positive? So everything is positive. You can see that all of these values are positive. The whole of this graph will get reflected on the x-axis but below the x-axis. This is what the modulus over the y would do. So this is the graph that we have. Everything will get reflected below as well. So I am drawing it using another color. So in this video, we dealt with graphical transformation. I hope you found it really interesting. And if you watch this nicely and understand it correctly, largely you will see that you won't require any more videos or any more things that you need to refer in order to get the transformations right. But what you will require is a lot of practice in doing that. And in order to help you out, I have given the homework in the PDF of this lecture notes, in which you will find lot of interesting questions that will become basis of problem solving in JEE Main Advanced level. In the next video, we are going to deal with equations based on modulus. So it is going to be a very interesting one, because whatever we learnt in the first and second video, we are going to use it to solve real problems based on modulus. So do not miss the next one. See you in the next one. Bye bye.